Hi, everyone. Welcome to Science Disruption, the podcast that investigates how disruption can become an integrated part of science. I'm Moti.
I'm Uri.
Hi, Uri.
Hi, how are you?
Okay. Today, we want to compare the high-tech industry with science in terms of progression and disruption. A spoiler alert, we found some amazing patterns that exist both in science and in the high-tech industry. The idea is that when you go forward with science research and high-tech innovations, you have like a linear progression, incremental progression, but then from time to time, you have like a spike, like a breakthrough disruption that changes not maybe everything, but some things. And this is like a phase transition in physics or in science. We want to in this episode, we want to see what disruption is, how we can quantify it, how we can maybe promote it or create more disruptions in science. And this is where our recent paper comes in which we try to find the patterns or the ways of disruptions in science and in high tech. So let's start. The first question that comes in mind is, let's talk about science because this is what we focus on. There is a feeling that science is a little bit stuck, not everywhere, not in all disciplines, but in many disciplines, it is stuck. It is just progressing, not creating breakthroughs. So maybe, Uri, you can talk about it a little bit.
Yeah, so when we learn how to do research as students, and we learn how to publish papers, we know from all the experience that we should go step by step. First, we find one thing, and then we publish, and then we find another thing, and then we publish. Because if we come with ideas that are too ambitious or too progressive, nobody will publish them, and nobody will give money for the science. So we don't produce major leaps. So this is what we call incremental progression. So we go step by step. We evolve from one protein to another, from one discovery in the ocean floor to another, but not a major leap. We have some major leaps, but there are so few that we can put our finger on them. We can count them on one hand or two hands. And this is for several decades. It's not every week. One of the purposes of what we're doing here is, first of all, to put a mirror to science and show them you're progressing or we are progressing step by step. But on the other hand, we want to progress really, really fast. So how can we do that?
So let's put it in like a philosophical context. About 50 years ago, Thomas Kuhn wrote his book about how paradigms are shifting. What's the shifting paradigm in science? And the idea was that there is always a mismatch between your theories and observations, and they don't match. There's no 100% match between the theory and the actual empirical evidence. But as these mismatches grow, after a while, you get a shift in paradigm, like Newton comes along or Einstein comes along and said, okay, I have a whole different view on what these evidence are. Yeah, that's true. But Thomas Kuhn didn't know anything about high-tech because there was no high-tech industry when he wrote his book. And currently what we see in the high-tech industry is a different behavior. It's not the same behavior like I feel uneasy, now it doesn't work with my theory. It's another thing. It's like a herd behavior when like finding gold in California. One person finds gold, everyone rushes in. It's a different behavior. And this is what we want to see if science adapted to, because science currently really acts like most of science, like Thomas Kuhn said, we feel uneasy. But currently, what if we really want to change science to go for the gold? So
to provide tools that will enable scientists to do more than incremental progression. Yeah. Incremental progression is what we learned. That's our comfort zone. but we want to produce another set of tools.
Yes. So, for example, let's start with some examples for disruptions in science and in high tech. So, in science, the basics are Einstein's relativity theory that changed everything in a specific discipline.
In plate tectonics was suggested many years ago, but in the 1970s, suddenly it caught. Until then, what we knew about the world, so many theories, but once we had the plate tectonics, everything got together. The problem is, since then, it's 50 years, more than 50 years now, we have more and more studies, but not a new paradigm.
So what happened is that it suddenly, you had this click that everything fell in place, all the evidence and whatever. There were some ideas going around, but there was not one theory. But then it worked so good, we can now go with this new paradigm. We can exploit it. We have so many low-hanging fruit that we can write about. And science just went into this incremental progression because, it's easier. It's where
within that paradigm. And then we ask, okay, that's it? That's what you can get? Only one paradigm and everybody is happy, so we have more low-hanging fruits, but with time, we have less and less low-hanging fruits.
Mm-hmm.
So what do we do?
Yeah, and the same goes to other, in my field of study, when you talk about Tversky and Kahneman with behavioral economics, it's about 50 years old, this paradigm, and it's a great paradigm. But when you compare a 50-year-old paradigm that still produces a lot of papers and appears in a lot of references, when you compare that to high tech, for example, let's talk about disruption in high tech. So the basics are the internet is a huge disruption. It changed our lives. Smartphones changed our life. Recently, you had AI and generative AI. Generative AI only began in November, the big mass of generative AI. It's like less than a year ago, and still everyone is talking about it. This is what we want to achieve here, right?
So if you go a step backwards, when you rent a house or you go to a hotel, you ask if you have electricity, if you have water, and if you have Wi-Fi. We need Wi-Fi, we need the internet. It's like every other basic need. And just imagine your life before that. And the same for smartphone. Once the smartphone was introduced to our world, we cannot go back. We have more and more sophisticated smartphones, but nothing really changes.
Yeah. So if you want to wrap up this concept, so what we see is that science is progressing slowly in many disciplines, and we can show the specific disciplines because we did a research about it. But the main idea is that if science is very close to technology, like AI, for example, or like quantum computing, it progresses rapidly and maybe creates a disruption. When science is very far from technology, it's very slow. And there is the middle, of course.
It's slow because in the incremental progression.
Yeah.
It's not slow. It's just the regular pace of science.
Yeah. It's slow in terms of breakthroughs and disruption.
Exactly.
You get great new research papers and great things are explored, but it all falls in the same paradigm, and it doesn't change the paradigm. It doesn't shift our perspective on things. It's the same thing, but with a better resolution, let's say.
Which is okay if you want to stay in the same paradigm. What we want to give is another tool, or to develop another tool that will enable us to jump from one phase to another, to introduce more phases.
Yeah, and also, when you do a lot of research, you have to get your priorities right. And with this, you talked about it a little bit before. So funding is what determines basically your priorities, right? I get funding for this and funding for that. And if you don't get funding for disruption, you don't do disruption. Maybe you could do more disruption, but you don't get funded for that. We will talk about it later. But let's now dive into the actual definition or quantification of disruption.
How can you measure disruption? There is no quantification tool to do that.
So what we did is that we talked about it and we tried to find a tool that measures disruption.
Do you have such a tool in the high tech?
No.
Okay.
It's only about feelings. I know that smartphones disrupted the market. And when I see lots of pitch decks and presentations by startups, and if you don't have the words disruption, tectonic change, or whatever, even if you just did a small plugin for something, it's a tectonic change. So in the high tech, it's like overusing this word. But basically, it's all about feelings, and people feel that something is disruptive. And even for the article that we wrote, and we got lots of comments, some of the comments were, yeah, but I know what disruption is, but then nobody knows what it is really. So first of all, we try to see how to quantify it. And basically, if you go to Wikipedia, you have lists of disruptive innovations or whatever, but this is qualitative. We don't want that.
How did the Wikipedia or any other place, how did they put this list together? Based on what?
This is like an expert's opinion, okay? So you talk to experts and they say, okay, there are lists for a specific scientific discipline. You look at the list, it makes sense, right? These are the articles that made huge changes, breakthroughs in this specific discipline. But why have they been chosen? You don't really know. It just seems reasonable. But then if it's also reasonable, you want to go to the next step. And the next step would be to have some kind of measure or index. So the basic measure that you have in science is the number of references, impact factors, whatever. Maybe you can say a few words about them.
Yeah, and so the measurement is not only for peer-reviewed papers, but also for promotions and for job interviews. How many papers do you have? How many citations? In which journals did you publish? What are the rankings? These numbers really count because people are counting on these numbers for all these important junctions in your professional life. So the question is, how important are these numbers? Do they represent anything? And so let's see what you did.
Yeah. Okay. So what we did is we say, okay, let's leave all the experts' opinion. Let's go to the basic behavior here. In economics, there's a concept, revealed preference. And revealed preferences are the things that people actually decide to do, what you see in their behavior. It's not something that you say, okay, he was thinking that, he wanted that, he wished that. No, he just went to the store and bought this bottle and not that bottle. Okay, that's it. The revealed preference is the actual behavior. So if we take this principle and look at science and at the high-tech industry, because what we want is as one index that we can use for both science and the high-tech industry in order to compare them. So we thought about revealed preference, and the idea is that we can see what really happened in terms of a major parameter. So for high-tech, a major parameter could be the number of investments in this specific field, let's say in AI. And
why not the size of investments?
Yeah, so could be the number or the the dollar amount of investments, okay? Which are two sides that they have different perspectives, because you can see if it's a herd behavior, like if the number of investments are huge, this is like a herd behavior. Or if you have like Microsoft deciding to put $500 million in a company, it changes. It's like an outlier for what's happening, but this is another clue of where the industry is going. So we thought, okay, for the high-tech industry, we can take these kind of parameters and see the behavior. For science, citations or references, this is like the only thing that we can take. So we did we cut some outliers, whatever, and we said, okay, let's take the most cited articles. Let's see what happens to them. And the basic idea was to see how people are referencing the other articles, or in the high-tech industry, they're just putting in the investment money. And there is a herd behavior in both cases. So also in science, you have this major article that everyone has to put in their references, right? And this is where we started. This is like the base point.
So in science, just to clarify, in science, we went to Web of Science, where you go for most of the promotion to fill your CV with all the numbers. And we took in 5 different disciplines. We took the 10,000 most cited papers of all times from their database that goes to the 1980s until now.
Yeah. So we took about 20 disciplines from science and from high-tech, and from science that is very close to high-tech. We called it tech science. And what we found is that you have the same pattern. This is let's show some graphs. We found the same pattern in science and in the high-tech industry in different fields. For our listeners, this is a graph. We're seeing a graph right now, and maybe you want to explain it.
Yeah. So on the horizontal axis, we have the years since the mid-1980s, and we have on the left y-axis, we have the remote sciences disruption index. And Moti will talk a little bit about the disruption index, but we have there graphs of 10,000 most cited papers in statistics, in psychology, in economics, in geosciences, in mathematics. And then in another group of graphs, we have the tech sciences, still sciences, not high tech. For all of them, the disruption index. And over there, we have quantum computing and artificial intelligence. And for them, we have publications since the year 2000, more or less, because they didn't start in the 80s.
But then what we saw is that you have a specific pattern here, and the same pattern in the high-tech industry, but very rapid and active.
So let's talk about the pattern.
So the discipline starts with an exploration phase where you have a low level of disruption activity.
Like a plateau.
Like a plateau, a small increase in activity. And then you have like a disruption point, the point where something was happening. You found something, there was a breakthrough. And this is where everyone is starting to look at a specific discovery or article. And then you go to the second phase, which is the exploitation, the low-hanging fruit. Because once you have a new paradigm or new idea, you can exploit it. You can do like derivative research, and then you have a steep exponential increase. And then you go up because the number of papers here, or in the high-tech industry that we'll show soon, the number of investments go very, very fast, very, very high, because everyone wants to go to this new discovery. But then after a while, you get all the low-hanging fruit. You get to a plateau where it's not changing very much, and then you go downwards. And downwards, we call it the exhaustion phase. So to conclude, you have exploration, exploitation when you go up, and then maybe a plateau, and then an exhaustion when you go down.
And this is for the disruption index, what we see for the sciences, the remote sciences.
Yeah. you have the pattern, but it's very slow. We use all these statistics, correlation, whatever, to show that the pattern really exists. And if you're watching it, you can see the pattern. Just about artificial intelligence, quantum computing, etc. These are just beginning to grow up. You can see in the graph the exploration, the exploitation, but we haven't reached the plateau. Artificial intelligence is maybe entering the plateau phase, but we don't know. Let's maybe go to the other slide.
But before that, the exploration that you talk about, it's like nothing really happens, maybe just a little bit, and then suddenly the increase.
Yeah.
What is amazing here is that we see the same pattern in all disciplines, which are remotely connected, statistics and geosciences and psychology and economics. And we ask, why do they all behave the same? The same. That was a big surprise for us. We expected to have some breakthroughs in economics, in mathematics over the years, since the 80s and until now, to see that some breakthroughs or major papers or findings shifted the entire discipline. And suddenly we will have more citations for that year. But no, all the disciplines behave the same.
Yeah, so here we have another graph, if you're watching it, where we try to see high-tech categories of investment as they are presented on Crunchbase, which is a recognized engine for this kind of data. And we see the same pattern that we saw for the science fields. We see that you have the exploration phase, then a disruption point, then it goes up exponentially. Then there is not a plateau, and then it goes down on the exhaustion period. And you can see in the graph that there are some high-tech categories like SEO for search engine optimization, or mobile advertising, or social media, where you see this pattern that goes up and goes down because it's an old technology. And when you go to other categories like big data or 3D printing, you see that we entered the plateau or the exhaustion phase. And if you go to the newer categories like quantum computing or insurtech, we just wanted to put in some very random category here. We see that they go up and not really going down. Most of them are not really going down. But for example, virtual reality, which is a category which was considered to be like a huge thing, we see the very good pattern going up exponentially, going down exponentially. And in the article, we also do some analysis of the statistics of these patterns, and we see that they all behave in the same way, but they have different, let's say, velocity, how they go up, how they go down.
So this is, again, a disruption index. And as you said, all the calculations appear in the article. The link, by the way, is in the description. But here we are basing our findings on the amount of investments. In the science disciplines, we based our calculations on the publications, citations. So these are two different things, but still the behavior is the same.
Yeah, the idea is revealed preferences is the behavior, the underlying behavior, and the number of investments or the number of citations is just a proxy to this behavior, this hair behavior that characterizes disruption. Okay, so we cannot say if virtual reality is a disruption or not. Could be, everyone was talking about it for a while. We don't really care about the quality, just the quantity. So virtual reality showed a herd behavior, and therefore there was a disruption point in our terms. It's important to say that, because some of the comments that we got is that this is not how the person that wrote the comment defined disruption. Yeah, right, because disruption is currently not really defined in a index or measurement terms. Okay, so here is the general idea of how disruption works in both science and high tech. And it's what we talked about. You have exploration, then exploitation. And in science, and this is where we start with providing some insights, science is not really good in identifying disruption points. We mean not only researchers, but also funds and universities and governments. Usually they don't identify disruption points fast enough, and they don't respond well to disruption points. They really like either the exploration phase where nothing happens or the exhaustion phase where nothing happens. And they want is the exploitation, the low-hanging fruit, where you can just go around and explore and create a lot of good science.
This is kind of looking for stability, because when you have many low-hanging fruits, you know that your investment in this particular project will bring fruits.
Yeah, you cannot go wrong. The basics in the startup industry is, let's say you have a new startup, and in the first year or so, you may have 2, 3, 4 pivots. A pivot is when you take your startup and you say, okay, this is not my business model. This is not my product. This is not my audience. I'm doing something else. And I'm not sure that, maybe you can tell me, in science, if you have like a research project, if you can do 2, 3 pivots during the first year. I'm not sure that you can do that.
I don't think so, because if you get money to do a project, you need to deliver, you need to submit reports, you need to follow the guidelines, your research proposal and your timeline. If you want to do something else, wait for the next one.
Yeah. So the stability part of science is countering this pattern that we see. And this pattern is like the law because of the behavior aspects of disruption. Okay, it's because this is how people are acting, and they create this exponential power laws here, and science is counteracting them. Science, like in general terms.
Yes.
So this is the basics of what we showed in the paper.
Yes. So these basics gives us a strong feeling that there is a basis for comparison between high tech and science. And we see a pattern, a similar pattern in both disciplines. And that's why we feel there is a basis for taking some of the insights from high tech, implementing them into science. And as we said before, we know how to do incremental progression, all of us. Now, let's learn how to do disruption and add these basic tools to the incremental progression tools.
Yeah, and the purpose of this article, and there will be follow-on articles, but the basics is we're talking about science, and science starts with a question, then some kind of quantification of the question, okay, or measurements or evidence, and then after we have some kind of a model or index, let's see what are the insights that we can do, we can have after we have this quantification. And here, in terms of disruption, there are some high risk, high reward funds, but it's the beginning of how to measure this kind of disruption. So the idea is to say, let's develop some measurements of disruption. This is the first step. Let's see the differences between the scientific fields, between high tech and science. And then we can take the next step of changing the world. Okay. So this is like a first step here. And this was the idea in this article.
Yeah. So first, science needs to face the reality, and then to strengthen the disruption part. Because if we do that, we'll get more and more breakthroughs, more and more low-hanging fruits. And hopefully we will be able to advance science of all disciplines faster than we know now.
Yeah. And it's also fun to disrupt something, right? Great. So I think we just talked about the article.
Yes. I hope it was interesting for all of you to explore all these disciplines and numbers.
Follow us, talk to us. We want your comments, and see you soon on our next episode.